to take
again, this is an opportunity just to talk a little bit about models that we use in tensegrity and in biotensegrity. This is a tensegrity model. Here we have one here. It's called the Squish, and it was produced by the Manhattan Toy Company, but made by Tom Fleming. And so this is a child's toy. But the thing about this this particular tensegrity model is that it is just that. It is a model. And so that's why the knot is being highlighted here, because in a tensegrity model, you have two members. One member is a discontinuous member. So hence this strut or bar would be the discontinuous member. And many people would describe that as representing the bones. And then you have this portion, which is the tensional member, which is a continuous member. And this is why, as I say, the knot is highlighted, because you'll see that, of course, it's not truly a continuous member, because it's not infinite. It had to be tied off, and there's the knot, which is the evidence. So it really is just a representation, and it is a model. In human form, there are no knots in that regard. You are complete. You are continuous. You have continuity from the tip of your toe to the tip of your nose. And everything is truly connected to everything else. And so the argument that we would put forward would be that even in a tensegrity where they mention that there are two members, a compressional member and a tensional member, the reality of biotensegrity is that there's only one member. Now, that when we say there's only one member, of course, bones are harder than this stuff, skin and subcutaneous connective tissues and the collagens and so on that make up our connective tissues. So yes, there is a difference in terms of stiffness and hardness, but in dissection, the only way that I can produce a bone is to spend quite a bit of time and quite a lot of energy slicing the tissue off that bone, cutting the tissue off that bone. And when I do that, I will leave connective tissue on the bone. Or if I cut into the periost, then I take some of the periost with the bone. So they are not separate. It is simply a continuity of specialization along that continuum. So just bear that in mind as a difference between the reality of us being a biotensegrity and a tensegrity model, because tensegrity models are useful, but they can also be, I won't say they can be an enemy, but they can cause, they can cause misleading images and ideas and notions. So we need to be careful about the limitations that a tensegrity model provides us when helping to describe biotensegrity.